In this video, we're going to understand and use position vectors. From our previous learning, we understand vectors written in component form, such as the example here of the vectors 2i plus 3j. So using the vectors I and j, I being 1 unit horizontally and j being 1 unit vertically, we can have a look at these 4 vectors represented in this xy plane. Each of these vectors has the form 2i plus 3j. Looking at vector A, we can see that from its tail to its nose, we go 2i and 3j up. Vector B has exactly the same vector in component form. It's 2i plus 3j. What we notice about these vectors is they're what we call free vectors because they're floating within this plane, because they have sort of no reference point or fixed point that we can talk about them from. So what we're going to do now is give vectors some kind of position or have them as a fixed vector. And this is where we measure them from a point, and that point is the origin. So we're going to have a look at vector OA. We can put an arrow across the top of that. This is a vector going from the origin, 0, 0, to a point A. So let's use the point A as 3, 4. So we're going to go 3 across and 4 up. So there's my point A. So the vector from the origin to point A is a fixed vector. And we can write that as, in component form, 3i plus 4j. We could also write it as the ordered pair 3, 4. But that is the point A from the origin, a position vector. So let's see this in action in our first example. So we've got points A and points B who have position vectors as follows. So let's pop them on our xy plane. So point A is 2i plus 3j. And point B is negative 4i plus 5j. So we've placed our points on. So what we want to do is draw in that vector from the origin for each of those points. So our next task is to define the vector AB from A to B, in that order, in that direction. So we know that when we're trying to define a vector, we need to go from its tail to its nose. So for us, that means we're going to have to travel back along vector OA, but in the opposite direction. So we want to go the negative direction of vector OA, and then we want to travel along vector OB. So we want to add on vector OB, and that will give us vector AB. So if we consider this, I'm just going to use the ordered pairs as an easier way of writing it. We want the negative of OA, so the negative of 2, 3, plus vector OB of negative 4, 5. So we're going to put together our I components first of all. So we've got negative 2 take 4, so that will be negative 6. And our J components will be negative 3 plus 5, and that will give us 2. So vector AB is negative 6i plus 2j. And if we have a look at that, we can see that we've actually travelled 6 units to the left and 2 units up. So negative 6i and 2j does make sense. Now we'd like to find the magnitude of this vector AB. So because we have that idea of a right triangle that's been formed, it's nice and easy to use Pythagoras to calculate the magnitude. 6 squared plus 2 squared will give me the square root of 40, or 2 root 10 units. We also want to find the direction as a standard position angle. So if we could consider this vector AB, and we extend out a positive axis from the point at the tail of this vector, the angle we're looking for is a standard position angle from the positive x-axis we've drawn in. So we could easily find angle theta within the triangle that we formed. So let's say that that's going to be the tan. The opposite side is 2 over the adjacent of 6, and that will give us 18.4 degrees. However, the actual direction as a standard position angle will be 180, take 18.4. So we can say that the angle is 161.6 degrees to a positive x-axis. So when we draw in our position vectors, we can then use them and the addition or subtraction of vectors to work out the resultant vector AB. So let's take a look at a couple more questions to do with using position vectors. So points A and B have the following coordinates. So straight away, I'm going to draw myself some axes. I'm going to place point A at -5, -10. And I'm going to place point B at 2, 8. So drawing in those position vectors, I'm going from O to A and O to B. So what I want to do is find vector AB. So it's the vector from point A to point B in that direction, a long vector here. So in order to do this, I need to go from the origin, from the tail of AB, I need to go back to the origin from point A, so that's the negative direction of vector OA, and then using vector OB. So in doing so, I want the negative of -5, -10, and 2, 8. And this is going to leave me with 7, 18, or 7i, plus 18j. Now finding the direction that this vector is going with, I'm going to draw in that triangle so we can clearly see that 7 across and that 18 up. And I'm going to have a look at this as a standard position angle. So I want the angle theta within that triangle. So the tan of theta is going to be 18 on 7. So the angle is going to be 68.7 degrees to the positive x-axis drawn from that point. Let's have a look at question 2. A particle has an initial position vector of 2a plus 9j meters with respect to an origin. If the particle moves with a constant velocity of 2i minus 5j meters per second, determine its position after 5 seconds and how far it's from the origin at this time. So our first thing is that we need to draw a diagram to show where this initial particle is positioned, and that's at 2, 9. So I'm going to call it P. It is moving at 2, -5. So it's going 2 across but 5 down, and 2 across and 5 down each time. So we can see that it's actually moving in this direction from its initial position vector at 2i plus 9j. So I'm just going to draw its initial position as a vector from the origin. So what we want to find out is where it is after 5 seconds. So let's call where it is after 5 seconds position 2. So in order to find this resultant vector from the origin, I need to travel from O to P and then from its initial position down to where it will be 5 seconds later. So I'm going to say that the vector of position 2, the position vector, is going to be its initial position plus 5 seconds worth of its velocity. So I'm going to say 2, 9 plus 5 lots of 2, -5. Now this is going to give me 2 plus 10 is 12, and 9 take 25 is negative 16. So the particle has a position of 12I take 16J meters after 5 seconds. How far it is from the origin at this time? Well, that's fantastic, because we know from the origin it has gone 12 across and 16 down, and that's its final position after 5 seconds. So we can find the magnitude of this, which will be 12 squared plus 16 squared, which is the square root of 400, which will be 20 meters from the origin after 5 seconds. What I'd like you to do now is have a go at question 3, where you're given two resulting vectors, st and tr, and you have to find the position of point S if you know the position of point R. To give you a hint, start with finding position vector OT before you find the position vector OS. Let's see if we can get the position of S as 4I plus 4J. And then I'd like you to have a go at question 4 and 5 and bring those to our next session.